In this episode of the Smart Community Podcast, I have a brilliant chat with Michael Milford, a Professor of Robotics at Queensland University of Technology. You may remember Michael from an earlier episode, way back in episode 22, when we were still called the Smart City Podcast, which was actually over 18 months ago now. So I wanted to have Michael back on the show to share what's changed in the autonomous vehicle space in that time. And he's the perfect guest to kick off Mobility March. In this episode, Michael and I discuss some of the projects he's been working on to do with infrastructure and road readiness for driverless cars, and the key problems with automating driving in complex urban environments versus highway driving. He tells us about the use of high-resolution maps of the environment for the functioning of autonomous vehicles, and how cooperative vehicles and connected vulnerable road users fit into this space and framework. We talk about the technology development in the driverless car space that Michael has seen both overseas and in Australia, and the maturing of the autonomous vehicle dialogue in the Australian context, including how Australia is embracing research and development of off-road autonomous vehicles, such as in mining, agriculture, and defence. Michael and I also cover the different types of data that underpin and spin off from autonomous vehicle technology, and the ongoing conversation around ethics of automation, as well as the emerging trends we need to talk about more, such as the implications of autonomous vehicles intersecting with public transport and ride-sharing. As always, we hope you enjoy listening to this episode as much as we enjoyed making it.
Welcome to the Smart Community, Smart Regions, Smart Towns, and Smart Cities. It's where we live, work, and play. With smart communities, the future starts today. Big data, smart mobility, emerging trends galore. The Smart Community Podcast is what you're looking for.
Hello, Michael. How are you today?
Good morning, Zoe. I'm fantastic. Thank you. How are you going?
I am also fantastic. It's a beautiful morning here in Toowoomba, so I'm so excited to talk to you.
Oh, you're not covered in rain at the moment?
No, very brief hiatus from the rain, so it's quite nice. But yeah, I think it'll pour down again probably in, this afternoon or something like that.
Cool.
Let's jump straight in. And can you tell us about your background and what you're passionate about?
Sure. So I'm currently a professor of robotics at QUT, Queensland University of Technology. I do a lot of research around all things to do with robotics, autonomous vehicles, especially in the areas of sort of mapping systems, navigation systems for these platforms. We do a lot of basic fundamental research, but we also work with government and industry partners to try and translate some of those discoveries or findings into technology or, I guess, policy input for the government. I'm also very passionate about scientific outreach and science communication. I believe one of the really important things we need to do is make sure that everyone in society is really well informed about all of these potentially transformative technologies that are just around the corner or are already here. So I spend a lot of time doing that around Australia and overseas as well.
That's awesome. Now, if you think Michael sounds familiar, you're correct, because he's been on the podcast before. Way back when we were the Smart City Podcast, it was May 2018. So that was episode 22, which was really exciting. So I wanted to get Michael back on to kind of give us an update of what's been happening, because so much has happened in that time.
It feels like ancient history, doesn't it? 2 years ago, barely 2 years ago.
It's a bit crazy, actually. I need to go back and have a listen to what we talked about back then again, and then see and then really compare, because so much has happened in, 18 months, say. Yeah, it just moves so quickly. But let's first just give the listeners a bit of a refresh. What really sparked your interest in this autonomous vehicle space?
Sure. So I'm a tech head at heart, and driving a car is like a remarkably interesting problem to study from a scientific perspective, first and foremost. So everyone is interested in artificial intelligence for robots and just in general in terms of research. Driving is a really nice domain to sort of study an aspect of artificial intelligence because it's a really challenging task, but it's not everything. So it's like a constrained version of artificial intelligence. So it's a really great way to try and advance our understanding of how we can make AI better. From a technological point of view and an outcomes point of view, I guess it's very interesting in that if we manage to make autonomous vehicles that work really reliably and really safely, that has all sorts of hopefully mostly positive implications for cities, transport, mobility, everything about how we go about our daily lives. So that's also fascinating to sort of work through the future as it could be there.
I've heard you speak on this topic, obviously, and when you were talking about that we need that human level of intelligence to be able to operate an autonomous vehicle, fully reliably, how far along that track are we to actually get to that point where we could actually just jump in and it could go from our house to our workplace or whatever, actually doing that all in autonomous mode?
That's the fascinating thing about it, is the honest answer to that. That hasn't changed in 2 years or indeed more time. That we don't really know. That's the thing. Because it's such a complex task, we know a lot of the elements that have to go into making a car that can drive itself reliably, and people have got most of the way there. The technology that you see out on American roads, for example, in testing is pretty incredible, but it's all the way there yet. And that last, whatever you call it, 1%, 0.1%, is bridging that gap. It's still a huge unknown. The thing that has changed, even over the last 2 years, is that pretty much every person is completely aware of the fact that we don't know, and that it may take quite a while, if at all. So the average level of awareness has continued to improve over the last 2 years, which is fantastic.
What are some of the other things that have really changed over this last kind of 2 year period?
In autonomous driving, I guess you've continued, because of these ongoing challenges that are not yet solved fully, we're continuing to see pivots. So some of these companies are refocusing on selling the sensors for autonomous car research. Some of these companies are focusing on autonomous delivery vehicles. They're attractive for a number of reasons. They don't have exactly the same set of challenges that a passenger carrying robot taxi has. And so some people think that they're closer to widespread commercial viability than the cars that would carry around people.
I've been thinking, and I was chatting to Robert Bell, who's the Intelligent Communities Forum director in New York. And particularly in, I guess, Australia and America, we have these quite long distances and, without kind of public transport in between, say, Toowoomba, Brisbane, even, Sydney, Melbourne, that type of thing. And when we're talking about highway driving, that seems to me like an easier task to do. Is there a focus on getting that part right first, then deploying? Because it feels like the hardest problem is, when we're navigating the streets where there's so many interactions. Any thoughts on that?
So that's very much true. The key problems are navigating in complex urban environments where they're mixed environments with lots of pedestrians and cyclists. That is fundamentally the largest challenge in the field. Highway driving has long been a target for autonomous vehicle development. They had reasonably good highway driving in, the 80s and 90s even. They were able to drive fairly long distances in autonomous mode. Elon Musk, I think, makes the case that Teslas on the highway are now safer than the average human driver. I think that still needs to be sort of fully verified or checked, but it is plausible on highways only that the autonomous tech is at the point where it is potentially better than humans. I guess commercially, that's not anywhere near the sort of autonomous vehicles everywhere. That's people who can afford one of the more expensive cars like a Tesla, and you'd adjust on the highway, but they still have to drive it once they get off the highway. And of course, that has implications for all these promises about increased access to transport for people with vision impairments or elderly or people who couldn't otherwise drive, because in that highway-only autonomous driving model, people still need to be fully competent drivers, and they also need to supervise the car constantly. So it's sort of a limited subset of society that can access that.
Yeah, no, that's absolutely right. And when we talk about autonomous vehicles, there is this talk about, increasing access and focusing on that, and which I think is very important. And if we're only, increasing that divide further by allowing certain segments of society that already have access to a vehicle. Yeah, that's really interesting. And I know you've been doing some work on kind of the readiness of the roads for, say, Queensland. What are some of your key takeaways from the readiness of our infrastructure?
Sure. So we had a project that just completed recently with Queensland Department of Transport and Main Roads and the iMove Cooperative Research Centre plus some other partners. And that particular project was assessing how well current autonomous vehicle technology would fare interacting with the static infrastructure that we have on sort of southeast Queensland roads. So we are looking at things like how reliably detectable are traffic signs, traffic lights, the lane markings on the road, where they exist, and how well will the car be able to sort of position itself, know where it is in the environment. So we deployed a bunch of state-of-the-art sort of AI technology that does these various tasks. We trained it and customized it for Australian roads, and we also looked at the use of prior maps, using high definition maps of the environment to further improve the performance of the car. I guess the full report will be released shortly, but in terms of what we can talk about, broadly speaking, we found some interesting outcomes. First of all, that under the extreme performance requirements of autonomous vehicles, where you pretty much need everything to work 100%, it seems unlikely that without the use of prior maps, that's going to be achievable in all environments. So the use of maps of the environment seem to be a critical element of any successful deployment. And also things like changing roads and rural roads. So if the roads don't have line markings on them, that can be somewhat more challenging for these technologies. And most of the work in the sort of commercial space has occurred in urban environments where there are lots of lane markings. So this whole question of rural roads without lane markings hasn't been investigated as thoroughly. Things like road work, challenging weather, nighttime conditions, these are all issues that the technology doesn't do quite as well at solving currently, and that may need to be compensated for either with better technology in the future, maybe some modifications to infrastructure, or other solutions.
Going back to the mapping, just so explaining that a little bit further for people that might not be in this space. So that means that we need to map the area first before, the autonomous vehicle can operate safely. Is that what that means? So we can't just kind of go into an unknown environment and I guess let the autonomous vehicle just find its way?
Yes. So I guess if you took a broad consensus, with the exception of maybe Tesla, of what's happening in these big autonomous vehicle companies, what they do is they use the cars, have the cars drive through the environment and create very high resolution maps of the environment. Those maps are also typically annotated by humans to point out where turning lanes are and to provide extra cues for the car in the map. And then when the car is actually deployed in autonomous mode, it's keeping track of where it is in that map. And by doing that, it has all sorts of expectations about what it might be seeing or should be seeing in the environment. It will know that it's coming up to a stop sign or coming up to a traffic light instead of sort of being surprised by it and having to purely observe it with its cameras. It knows that there's probably something there up ahead on the road. And that makes a huge difference, generally speaking, to how well these systems perform. It's not a perfect solution because the world can change. And one of the big problems is how do you keep these maps updated? If someone suddenly installs a stop sign and the map hasn't been updated, there's the possibility of the map system actually making it worse because the car doesn't know about the stop sign and is relying partially on its prior map of the environment. So maps aren't a panacea sort of solution for everything, but they're probably going to be a key part of any deployed solution.
So how does Cooperative fit into this space?
So that wasn't the specific focus of that particular project, but speaking more generally, I guess Cooperative gives you some additional benefits, but not others. So Cooperative between vehicles and between some of the infrastructure that might communicate with the vehicles, obviously that allows you to optimize things like traffic management, allows the vehicles to talk to each other, which is especially useful if the only vehicles on the road are connected. If it's a mixed model, that doesn't really help you that much because you have vehicles that you can't talk to. The things that Cooperative vehicles doesn't really address that well is that fundamental challenge that everyone's trying to deal with, which is reliably operating around pedestrians and cyclists. It would help a little bit because the cars can share their observations of the environment and share their sort of ideas about where there are pedestrians and vulnerable road users. But that is only sort of a small assistance. It's not like a guaranteed solution to make sure that they're safe.
Yeah, we've been doing some work in looking at that connected pedestrian or connected cyclist or connected VRU, vulnerable road user, to see what can actually, what type of solutions could assist in that protecting people from, when we do have fully autonomous cars or connected vehicles or right now actually just making that safer for people.
Sure. And the challenge is that you can develop all sorts of technologies that make a big difference. It's just that the bar is so high. So if 1 in 10,000 pedestrians doesn't have that connectivity for some reason and there's an incident, that's just not acceptable. So the reliability that's imposed upon the technology that you deploy is extremely high in autonomous vehicles, which is, I guess, one of the key challenges.
Yeah, absolutely. And I think it's, if we go to comparing it to like the aviation industry, if we have one, plane go down, no matter how many, haven't, then we're all talking about it. Whereas at the moment for like the general driving, a traffic accident we're not completely shocked and, horrified about it. It's an awful thing that happens, but we've kind of accepted that certain level of crashes and incidents and that type of thing. But for then autonomous vehicles, we have set the bar much higher, which, I guess similar to aviation or maybe even more than that.
Yeah, and aviation is used as a good prior example of some of the issues in autonomous vehicles, but I sometimes think it's almost overused because there are like fundamental differences. Planes, once they're up in the air, when something goes wrong and there's a pilot in the seat, you typically have a little bit of time to react. Obviously, with autonomous vehicles, typically you have sort of sub 1 second to react, and it's not enough time for a driver who's not paying attention to take over, or even a remote operator to take over. So there are some good analogies, but I think sometimes people take them too far.
Yeah. No, I agree. And I thought you would jump in there because I think I've heard you talk about that before. But so you've done a lot of travel last year and probably the year before as well. I don't think we've caught up in person for...
No, quite a while, I think.
Yeah, we'll have to do that. But I'm keen to hear your thoughts about, a couple of things. So I'll just throw them all out there and we'll see how we answer them. Where you've been, what you've seen, and then kind of comparing that to where we are in Australia and some of the things you're seeing here.
Sure. So on the actual technology, I'll talk about a few different areas. The technology development area in anything to do with sort of driverless cars. Obviously, the hotspots for that are still primarily overseas, primarily in America, and primarily in California, where there are still a lot of major companies and startups operating. What I've seen is that there's been quite a bit of consolidation. A lot of the big companies are forming sort of collaborations with other big companies who you normally term as their rivals. A lot of startups are being acquired or acqui-hired into a lot of the companies. And there's not such a flood of new startups sort of working in the technology space. In Australia, the technology around off-road autonomous vehicles is sort of growing fairly rapidly. So things like mining and agriculture, those are growing areas of technology development. And some of that's being developed here, which is fantastic. In terms of on-road stuff, there's really still pretty much nothing happening. There's stuff on the fringes around driver vigilance monitoring and so forth, but there isn't a plethora of actual core tech companies developing on-road technology here. What is really happening here is that there's been a lot of assessment around the impacts of autonomous vehicles, and not just the technology, obviously, but societal impact. What will future smart cities look like? And the dialogue around that in Australia is much more informed and much more mature than it was even 1 or 2 years ago. So we've taken very big steps forward there, which is fantastic.
Yeah, I found the same, particularly, I think, in the smart city space. The conversation is maturing significantly, I guess, in information, but also just in, I guess, the concept of it, like that it's not going to be this utopian thing tomorrow, but actually we could use some of this smart, sexy, thinking and money and things that are floating around to actually solve some of basic problems that kind of got forgotten about, whereas now they're a bit more topical again. Like having access, like we were just, you were talking about before, if we're focusing on that, and that's, our aim is to, I guess, use autonomous vehicles, for example, to allow people to have access rather than just a wealthy person being able to increase, their productivity because they don't have to drive anymore, or also that safety aspect as well, if that's what we're focusing on. Yeah, so it's been really interesting to see that progression. And then, obviously there's so many things in smart cities, and mobility is just one of those, and seeing the hype cycle and where we're kind of currently at it's been really interesting.
My other pet peeve about the hype cycle is when people chuck, and I do this as well, when people chuck up that hype cycle graph, the implication of showing that graph is that the technology eventually becomes widespread and deployed. And obviously that's not always true. There are lots of failed technologies that up to this point in time have never actually made it to widespread deployment. And people show that graph quite often for sort of robo-taxis. And there's this implication with that, which is that it will get to widespread deployment. And I think we need to be a little bit cautious about just assuming there's a 100% chance that we will have these robot cars everywhere in 5, 10 or 20 years' time.
Yeah, that's so interesting. And that is so true, because it's also, and I'm not sure how much you're looking at this aspect of it, but is that actually what we want for society? Do we want to replace our current cars with autonomous vehicles and continue to, build roads and do those things? Or should we be focusing our energy in increasing public transport and those type of things? It's something I think about a lot. And, are we focusing on those, or are we just assuming that robotaxis will happen, therefore the funding keeps going into them and that type of thing? Or should we be pulling that up and kind of going, what do we actually want for our smart communities moving forward?
And the two of the key factors, and this happened with telecommunications, it happened with other sort of technologies, is obviously you have to deal with the current inertia of what society's expectations are around car ownership and transport and where they live and what sort of house and yard they'll have. So you have to, and you can't change those overnight. Those are obviously generational based changes. So even if you could deploy autonomous vehicles now, are people actually going to give up their cars? Because a lot of the benefit, which I think is overlooked or potential benefit of autonomous vehicles, is the fact that lots of people wouldn't own cars anymore. The not owning a car or the lack of private ownership is often a bigger benefit than the actual autonomy aspect. So dealing with the current infrastructure and the fact that you can't change things overnight, those sort of affect the feasibility of these technologies as well, of course.
Something I've been thinking about as well, we talk about autonomous vehicles for the access, and that, right now, people that don't have access to the network, they could have access to the network with a driver and a car. So that autonomous component of it isn't the thing that's stopping people from getting access. It's the funding or the resources or the focus or whatever. They could have that service right now. I think that's something we don't talk about enough, is some of these things could be enabled by humans right now, but we're focused so much on the technology, that's all we're thinking about. And so when that's available, who's to say that service would be available? Because right now it's not. And if we don't focus on that and all those other components that would be required for that, the technology is only one of those, all those human behaviors and factors and funding and resources and allocation, all those type of things need to all fit together for it to actually be a service that, somebody that we can high five about, that, we've given somebody access.
Sure. And it has to be financially sustainable, whether it's a government operation, government subsidized, or a purely private operation. And obviously another challenge there is the fact that all these ride-sharing companies have come in, they've massively, initially at least, undercut the fees that they charge riders. And now there's a lot of analysis of whether in a current model, any of these ride-sharing companies are actually profitable in the long term.
Yeah, no, absolutely. And then, all those things about the humans that are actually driving the cars now as well, is that sustainable moving forward? And is that something that we want to be promoting as, smart mobility, if people aren't getting paid appropriately and it's not sustainable and we're just, going to ride it out until we can't anymore? It's an interesting topic.
Yeah, definitely.
Okay, well, tell us about some of the other projects and things that you're currently working on.
So we have a bunch of new projects actually starting this year in areas around technology and autonomous vehicles. I can't actually talk too much about them yet because none of them are public. But I guess, as I mentioned before, Australia is particularly strong in leading the world in many aspects in technology development for autonomous vehicles that don't operate on the road, so that operate in other environments, and will be heavily involved in a number of projects in that space. Obviously, in general in Australia, our strengths are things like agriculture, mining. There's growing investment in sort of the defense technology in Australia and a few other areas. So while we don't have lots of startups doing on-road autonomous vehicles, we do have a lot of research and technology development in these other areas, and we're working heavily in that space.
That's awesome. I'm keen to hear what your thoughts are on, I guess, data, right? You know, you're looking at autonomous vehicles and all the data that's going to go behind it. Is that something that you and your team are looking at, or is that something else that will be considered further on?
So we're very much looking at the aspects of data with respect to the navigation system, the artificial intelligence systems that study the world around the car to work out what to do. But I guess the other part of the data play, which I assume you're also talking about, is all the customer data, the trip journey data, and all that sort of stuff. We don't do a lot of direct, deep study of that, but we do talk to people in the industry quite a bit about this. And behind closed doors, I think you're hearing a lot of the leading operators in this space talking about, said all the time, but data being their most valuable asset, and perhaps many of their potential pivots if autonomous driving doesn't play out is actually the play around the data. These companies can answer incredibly specific consumer questions about price tolerances and ride quality tolerances, and about where people shop and all that sort of stuff. And so they're interested in wondering whether they can monetize that. Obviously, there's a whole quandary of privacy and ethical issues around that, which are being studied pretty hard as well.
One thing I get asked about a lot is the ethics of autonomous vehicles, and something you probably get asked to death about. Is there anything new in that space that, you know, we haven't talked about already? You know, anything emerging in that kind of ethics and ethics of automation?
So the ethical trolley problem, where the autonomous vehicle has to decide between two hard alternatives, that is still talked about, but there's been a lot of pushback against it. We actually released an article on this relatively recently. One of the practical challenges is that most autonomous vehicles, especially at long range, they really can't tell the difference yet between an elderly person versus someone pushing a pram versus a criminal, which was one of I think the MIT Moral Machine asked people who should be hit in an accident situation in that widespread international survey. So practically, the cars often don't even have the ability to differentiate between different types of people. So it's sort of practically not yet a relevant question, although people should still think about it. In terms of where everyone's consensus is at, I guess people are aware that these vehicles will be held to an extremely high standard. As I've mentioned before, I think one of the benefits of autonomous vehicles is you won't be guessing at all if there are incidents. You'll have pretty much complete data about everything that happened, why it happened, what happened that can be analyzed post any incident. So that is one of the benefits. Everything will be, assuming the companies are forced to share it, everything will be very transparent in terms of what happened. And that means that there's room for continual improvement in terms of how we manage and regulate and operate these systems.
So we talk a lot about integration, and I guess for the autonomous vehicle space, you've got the private sector, the public sector, and it's probably not something that you are researching specifically, but what is the potential kind of integration piece that we either need to be having now or we need to have in the very near future between, you know, the public and private sectors?
So there've been like little forays into this, right, where ride-sharing companies have linked their ride planners to public transport ride planners, right, which sounds very attractive if it works well. So the promise is there. I guess the underlying problem is these ride-sharing companies are only going to exist if they think they're going to be profitable, or if for some reason they're also subsidized by government because they're providing an essential service. And a lot of the modeling around being profitable is that they grab a significant chunk of market share of transport around a typical city. And we know that there's problems in terms of already subsidized public transport being further pushed into even less economically viable territory because a significant chunk of their revenue base is gone, while at the same time we know that autonomous vehicles specifically are unlikely to be able to shoulder the load of mass transit requirements at peak hour. So the poor public transport system will still have to do that at peak time, but will be operating on a much lower revenue base. There are some analogies, I think, to things like solar power and the electric grid, which is not my area of expertise, but the electric grid has to be able to handle peak requirements. But at the time, it's not doing that, and it's not generating as much revenue because everyone has solar power. So these are widespread, commonly occurring issues with these technologies as they come in.
Yeah, I agree. And I think that's something we need to talk about more in this space of mobility is the public transport, implications, the implications for public transport. But yeah, what do we actually want to focus on? We could be focusing on autonomous technology or increasing connectivity for buses and trains and that type of thing. But that doesn't seem to get as much media attention because it's not super sexy.
Yeah, well, you can look at past precedent, like how long it took, and I'm not saying companies are saviors by any means, but how long it took some of these companies to even integrate some of the public transport journey planners into their map-based journey planners. That my understanding is that took quite a while in some instances. And what we're looking at now, like complete integration of ride-sharing services and public transport, you can imagine that being quite a hurdle to overcome.
Yeah. So what are the emerging trends that people aren't talking about enough?
Oh, that's a good one. So I guess there's this whole data play, as you mentioned, behind the scenes. So everything that moves and consumes and communicates in any smart city, I guess the AI technology that's able to process that data and infer trends or make predictions, that's still progressing pretty steadily behind the scenes. It's obviously understandably restricted by barriers like between different interface barriers where you can't get communication between different sectors of the smart city, and you don't want to just give everyone's data, of course. But the AI technology is advancing steadily behind the scenes, even if it isn't yet driving autonomous vehicles around the place. And that's pretty. Some of that's pretty opaque because it's quite sophisticated and it's dealing with sort of very high multidimensional data. So it's not necessarily very intuitive to think about for everyone.
Mm-hmm. Yeah, it's really interesting. I think, everyone's talking about AI and the advances of AI, but AI in itself, unless there's an application, it'd be so different, right? Like it's just kind of like a topic and a buzzword, but the deep technical understanding of it is, I guess, limited to certain people, but then the applications of it are nearly, exponential if you think about how many services and things that are happening in a city. It's pretty broad.
Yeah, and I guess there are rules of thumb you can follow. So autonomous vehicles are challenging because you can't deploy an autonomous vehicle where the AI works 85 or a 90% performance level. It's unacceptable. There are, however, lots of other smart city applications where perhaps a complex service like telecoms or power or traffic management perhaps operates at 90% optimality now. And if you can find a way to safely test and deploy and refine an AI AI-based control system, and there's a clear sort of improvement you can make, and it doesn't necessarily have to be perfect. It just has to be provably better than the existing system, and you have to make sure there's no unintended consequences, like it's particularly discriminating against some subset of users. None of these are easy things to do, but where the existing system is not perfect and not necessarily anywhere near perfect, that's probably some of the most fertile ground for deploying these systems.
Well, it's been so great to chat with you, Michael. Thank you again for coming back onto the podcast, and we will have to catch up in person soon.
Yeah, probably overseas at some random mobility event, I'm sure.
Yeah, that sounds like a plan. Well, just one last question. How can people connect with you?
So if you hit me up on LinkedIn, that's probably the best way. If you want to read any of the resources or commentary that we talk about, there's a lot of stuff online. Just look us up.
Excellent. Well, thanks again, Michael, and we'll talk soon.
Cheers, Zoe. Have a great day.
You too. Bye.
The Smart Community podcast is brought to you by My Smart Community. If you're looking for support in podcast strategy and production, workshop design and facilitation, or communication and media advisory, Get in touch. Email hello@mysmart.community or head to www.mysmart.community.
Thanks so much for listening to the Smart Community Podcast. Show notes for this episode and all other episodes are available on our website, mysmart.community/podcast. If you have any questions for us or any of our guests, you can email hello@mysmart.community. You can also find us on the socials. We are on LinkedIn and Twitter at SmartComHQ. That's com with 2 M's. If you are enjoying the podcast, please hit subscribe so you never miss an episode. And we would love for you to leave us a rating and review at wherever you listen. This really helps us reach more ears and eyes, so thank you for your support. As always, we hope you enjoyed listening to this episode as much as we enjoyed making it.
The Smart Community Podcast is what you're looking for.